So my plan for the day today, we just talked about that. We're going to do one quick ranking task, and then we're going to work on the buggy lab that you started last time. Okay? We should be able to get almost through it, if not completely through it today. Homework for tomorrow, you don't have any additional homework except for to prepare for the retake if you are taking that. Okay? I don't want to put anything else on your plate. We will start some new stuff tomorrow after the quiz. Sound fair? Okay. Get out your notes because we're going to do a couple of ranking tasks and I want to make sure that you are with me. The setup for these two ranking tasks is a little bit funny, so please listen as I explain it, because if you don't pay attention, then it's going to make it really hard to answer the question. But they are kind of relevant to what we're doing with the buggies, which is why I like these and I wanted to put them in here. There are 4 situations. In each of the situations, you have a ball that's rolling along a line, kind of like we did outside when Courtney was rolling that basketball down the hallway. Okay, same kind of situation. So instead of having students standing there with stopwatches, so it's a little bit different. You guys know what a strobe light is? How they blink every fraction of a second? Okay. You can also use something like that to take photographs where it takes a picture every second. Okay. That's what happened in these pictures. The first picture is at time equals 0. The second picture is at time equals 1, etc. They just keep going. So like in A, this is time equals 0, time equals 1, 2, 3, 4, 5. You with me there? So this took 5, there were 5 seconds worth of pictures taken here. There are not 5 seconds worth of pictures taken here. That's okay. 0, 1, 2, 3. We okay? What's that? Kind of. Take a look at it. When you have questions, let me know. Is that fair? The question, the task for this one says to rank the magnitude of the displacement over the first 2 seconds. Rank the magnitude of the displacement over the first 2 seconds. So take a look at these pictures. I'm going to let you work by yourself first. Then I'll let you discuss in a moment. But right now, just look at it. See if you can figure it out. Go, go, go. So you and your brain first, and then I'll let you discuss. Why is there talking? So write down your best guess, your best understanding. The magnitude of the displacement over the first 2 seconds. All right, why don't you talk to your table mates now? See if you can figure it out. Come up with an answer.
So
So the dots are all, their pictures taken every second. So 0, and then after 1 second's passed, after 2 seconds have passed, after 3 seconds have passed. So this is 0, this is after 1 second, after 2 seconds, after 3 seconds. Does that make sense?
They're all none of them are equal. Well, except I got
second. I got D.
So like the first line, so 1 second.
You are, that is at 0 seconds. Time equals 0, that is true. So this one, for some reason, has a head start. I don't know why. Kind of wish I did.
Or maybe they missed it at 0 and accidentally. They all started at 0, but then D was slacking, so they did it at 1 instead of.
Well, if that's the case, then it got messed up, right? Yeah.
So then the second dot on all of them is at 1 second.
Correct.
So that A is at 2 meters, B is at 1.6. C is at 0.
That's okay. Talking it out helps, right? So just to make sure that we're all at the same place here, where is the ball in picture A after 2 seconds? What did you say? At 4 meters? Okay. Where is the ball in picture B after 2 seconds? 1 meter? How about in C? 6? Oops. Come on, little thing. There we go. And how about in D? It's at 9. Now, what is the displacement in each of these cases? In A, then the displacement is 4. This kind of seems silly, right? How about in B? How about in C? And this is kind of boring until we get to D, right? What is the displacement for D?
8.
Why 8?
Because it started at 1.
Because it started at 1. Remember, displacement is final minus initial. Does that make sense to everybody? Final minus initial. So it's 9 minus 1. So its displacement is actually 8. In this case, that doesn't really matter. Because the greatest displacement in either case is what? D, which is greater than, which is greater than, which is greater than, boom. How we doing? We okay? Let me give you another one. Similar picture, different question. This one says, rank the magnitude of the average velocity. So there are 3 key words here that I want to make sure you understand. First of all, what does the word magnitude mean? Absolute value. In this case, it doesn't really matter because it's not going backwards. They're all going in the same direction. So that's nice. Yay. Velocity. What does the word velocity mean? How do I find the velocity? It's something really specific, though. It's not just the distance. It's the displacement. And again, in this case, doesn't really matter, but it's going to later. So we want to make sure we're really paying attention. Displacement over time. I do want to say, because people have been asking me, and I just want to clarify, if you would rather write D here instead of delta X, that's fine with me. If you're more comfortable with that, if you're happier with that, do it, okay? The only reason that I write delta X is because that's what's on your equation sheet that you don't have yet, but I'll give you 2 soon, okay? And it's also the way they write it in the book because they're doing change in. But if you like D, write D. I'm totally down with that, okay? And then the other thing that's a little bit different in this question is that it's not over the first 2 seconds, but it's the first 3 seconds, okay? Give it a shot. You can talk to your table mates. Come up with an answer.
They made the So T is also.
But then C and A stay the same the whole time. It's greater and greater and greater. But B is less than A.
Is that knowing because we started out one, so you have to subtract?
Yeah, he's right.
All right, how we doing? Okay-ish. Leanne, did you guys come up with an answer back there? Can you tell me what it is?
C equals D, which is greater than A, which is greater than B.
C equals D is greater than, tell me again,
A.
A, and then B. What do you guys think? You agree with her? How are C and D equal now? They weren't equal before. What's different?
It said that they made the same amount of distance.
Yeah, because now we're looking at 3 seconds, right? So that 3 seconds, in that 3 seconds, C makes up some space, right? So it goes 1, 2, so it goes 9. This one goes 9 as well. Yep. B only gets to where? Here? And C or A gets up to 6. Cool. Nice job, you guys. Excellent. What can you tell me? Well, before I say that, questions? I didn't mean to go too fast. Questions on that? Okay. What can you tell me about the motion of ball A? Constant, consistent, right? Yeah, constant velocity. What can you tell me about the motion of ball B? What's it doing? Or something, right? In some way, what's happening to its speed?
Increase.
It's increasing, it's speeding up, right? We know that because if we look at velocity, it's change in position over time. The change in position is getting bigger and bigger and bigger every time, every second. Yeah. How about C? Constant. Does that mean that C and A are going the same speed? No. Which one's going faster? C is going faster, right? It's going 1 meter per second faster, it looks like, than A. And what about D? What's going on in D?
Going up. It's decrease.
We know that the velocity is drinking soda. What'd you say? What's happening to the velocity here?
It's decrease.
It's decreasing. So it might be going up a hill. There might be something else that's happening too. We're going to get there in about 2 weeks. Why and how and all of that. But awesome. Okay, that's great.